Hi friends, in this video I am going to explain about the how to write the magnitude and the phase angle equations from the given open loop sinusoidal transfer function. Clear? So here the concept is how to write the magnitude and the phase angle equation from open loop transfer function. Clear? So for example, we have open loop transfer function, sinusoidal transfer function. So I already informed you, I already explained about the whenever we are going to draw the frequency plots, first we have to substitute S is equal to j omega and write down the magnitude equation and write down the phase angle equation. After that, with the help of the frequency variations, then you will get different frequencies, you will get different magnitudes and different phase angles. With the help of all this only, we have to draw the plots. Clear? So for that, but before I am going to draw the what is that Bode plot or polar plot, actually how to convert or how to get or how to write the magnitude and the phase angle equations. Clear? So for example, open loop transfer function g of s is equal to k into 1 plus s into t1 divided by s into 1 plus s into t2 into 1 plus s into t3. So this is the open loop transfer function g of s is equal to this term given. Clear? Now I want the magnitude equation from this equation and also I want the phase angle equation from this equation. Clear? So here first, if I want to get the magnitude and the phase angle equations, first we have to just observe. So here k is a constant term and into 1 plus s into t1. If I substitute s is equal to j omega, then this term imaginary. It means what? 1 is the real part and j omega into t1 is the imaginary. It means with the help of this term, I can get the magnitude of this particular term. It means what? Square root of real square plus imaginary square. You will get you will get the magnitude for this term. Clear? So like that, we are also going to find the magnitude for 1 plus s into t2, 1 plus s into t3, and also here we are substituting s is equal to j omega. Then what is happening and what is the angle and what are the angles for these terms? For example, if I want to get the phase angle for this particular term 1 plus s into t1, then how to find? One is one is real part and j omega into t1 is the imaginary. It means to get the phase angle for this term, so directly we can use tan inverse of imaginary by real. So with the help of that, you will get the phase angle for this term. Like that, we have to find the phase angles for all the terms which are here. Clear? So k is a constant, there is no angle, that's why k is the magnitude and there is no angle, that's why 0 degrees. And here, so with the help of tan inverse of imaginary by real, you will get the phase angle for this term and also phase angle for this term and also phase angle for this term. Then what about s? So s is equal to j omega. J means what? 90 degrees. It means directly we can say that s is equal to j omega means omega at an angle 90 degrees. We can write like that. Clear? So now see here, this is the actual function he given. Now what I am doing, just I am putting s is equal to j omega in the open loop transfer function. Then I am writing like this. So instead of s, I am substituting j omega. So clear, this is the actual equation after substituting s is equal to j omega. Clear? Now here I want to find or I want to write the magnitude equation from this particular function. Clear? So now just see here, magnitude m is equal to magnitude of j omega is equal to k is a constant, but I want only magnitudes, I don't want angles. Clear? So whenever we are going to find the magnitude of this total equation, so I am considering only the magnitudes. Then how to find the magnitudes? Under root real square plus imaginary square. Yes or no? Now here, just see here. So after substituting s is equal to j omega, I am calculating the magnitude. M is equal to or mod of j omega is equal to k is constant value into so square root of real square plus imaginary square. It means what? 1 square plus j square omega square t1 square. Yes or no? So here j square means minus 1, and here remaining term is what? Omega square t1 square. So we are calculating the value of magnitude, that's why we can write 1 square plus omega square t1 square. So like this I am writing for this also and for this also. And what about here? So we have only omega is a magnitude, that's why we are writing only magnitude equation like this. Clear? So k, so 1 plus j omega t1. So for this I am using square root of real square imaginary square, then I am writing like this, divided by, so j omega, j is 90 degrees, but I don't want that, I want only magnitude omega into again square root of real square plus imaginary square. So that's why 1 square plus omega square t1 t2 square. Here also same, 1 square plus omega square t3 square. Clear? So this is the magnitude equation from the function. Clear? Now here I want phase angle. So I want phase angle. Now see, phase angle phi is equal to, or phase angle of g of j omega is equal to angle of g of j omega is equal to, so just see here, just see, angle of k is 0. So that's why I am not writing anything here. And here 1 plus j omega t1. So this is real plus imaginary. Then how to find the phase angle for this term? So we can directly find the tan inverse of real by imaginary. Sorry, imaginary by real. It means here imaginary is what? Omega t1 is imaginary. Real is what? 1. So that's why angle tan inverse of omega t1 divided by 1 divided by j how much? 90 degrees directly. I am talking about only phase angles. Clear? So j here j, that's why angle 90 degrees, and here 1 plus j omega t2. 1 plus j omega t2 means angle tan inverse of imaginary divided by real. That's why omega t2 divided by 1. And here also same thing. Okay, tan inverse of omega t3 by 1. So here tan inverse of this total term divided by 1. So like this we are going to calculate the value of what? Phase angle. Clear? So this is clear, but I want the phase angle equation like this. So how to write this phase angle equation from this equation? Just see here. So angle g of j omega, or phase angle g of j omega is equal to tan inverse of omega t1. So denominator 1 means there is no problem. Clear? So tan inverse of omega t1 minus denominator I have 90 degrees, angle 90 degrees. This is in the denominator. If it will goes to the numerator, then minus 90. But already you know that in case of Bode plot, the multiplication terms are always converted into addition. That's why denominator term, if it will goes to the numerator, then minus 90 minus again this one, denominator tan inverse of omega t2 by 1. If it will goes to the numerator, minus tan inverse of omega t2 minus this one last one, tan inverse of omega t3. Clear? So this is the phase angle equation. Now how to find the phase angle? Different phase angles means when we are substituting the values of different omega, you will get the different phase angles. Here also same thing, when we are going to substitute the values of different values of omega, you will get the different magnitudes. But whenever I am going to draw the Bode plot, I want to convert, or I want to represent all the magnitudes in the decibels. So that's why, so magnitude g of j omega in decibels. So how to write? Already I told you in the last video. So g of j omega in decibels is equal to 20 log g of j omega. So this g of j omega consider directly from this. Clear? So same equation I am writing here like this. Clear? Now so 20 log k into under root 1 plus omega square t1 square divided by omega into 1 plus root of 1 plus omega square t2 square into root of 1 plus omega square t3 square. Now 20 log. Now k by, I am simply writing all are in multiply. Yes or no? All are in the product, all are in product, but I want to convert into addition. So that's why what I am doing here, just writing separately. So k divided by omega is one term, just consider, and numerator root of 1 plus omega square t1 square, that's why only I am writing like this, into divided by 1 divided by root of 1 plus omega square t square, that's why I am writing separately 1 by under root 1 plus omega square t2 square into, and this one also 1 divided by this term, so that's a 1 divided by 1 square 1 plus omega square t3 square. Clear? So all are in multiplication form. Now because of the Bode plot, that is the main advantage, what? Multiplication terms are always converted into addition. So like this I am writing like this. So 20 log k by omega plus 20 log root of this term plus 20 log this term plus 20 log last one plus. Clear? So if it is in the denominator, we can also consider into the numerator by placing negative sign here. Clear? So if this term comes into the numerator, then sign will change here. Clear? So like this we have to write the magnitude and the phase angle equations from the given sinusoidal open loop transfer function. Clear? So in the next class I am going to discuss about the different factors available in the Bode plot. Thank you so much.